Hello everyone, this is Yanlin Liu, and this is a Big Data Analytics final project. And our project is video object segmentation based on pixel level annotated dataset. My teammate is Chong Hu. This is done by both of us with teamworks. So first, I will introduce our project. The goal of the video object segmentation is extract foreground objects from video clips, and it has many applications such as video summarization, video editing, object tracking, video action detection, and autonomous driving. So in figure 1, we can see these are the objects labeled by different colors. They are actually the separating foreground objects from the background region of a video. So here is the data. The data set we are going to use is Davis 2016, which is densely annotated video segmentation. It contains 50 video sequences with densely annotated, pixel-accurate, and per-frame ground truth segmentation. The right figure shows that how image label pairs are stored in the dataset. Also, the video sequence inside the dataset contains multiple occurrences of common video object segmentation challenges such as occlusions, motion blur, and appearance change. So the next we will do some data pre-process in Davis 2016. As for the data pre-process, we have two main parts. Well, the first one is processing data in the doing procedure and dealing with data in application. In the training steps, the image size we are going to use is 480p. Beyond that, we also use data augmentation such as flip and crop to improve the robustness of our model. There are 30 video sequences in the training set and 20 video sequences in the test set. We will use train set to train a model and conduct evaluation on test set. As for application, we provide functions use FMPEG to convert video to image sequence and render image sequence back to video. So the next we are going to introduce a model construction. The model we are going to use is one-shot video object segmentation, which has simpler network structure and faster inference speed. It won't occupy much GPU resources, and therefore this is very convenient to apply in industry. The first training step is use Davis dataset to transfer learning from pre-trained weight and learn how to segment binary foreground object. The second step is adjusting and fine-tuning the model for appointed foreground object. The network contains two branches. The foreground branch is used to locate the object's position, and the contour branch is used to get accurate boundary for the object. The loss function in training is balanced version of binary pixelwise cross entropy. Next is about the model evaluation. After we get a model weight from training dataset, we evaluate our model on test dataset. The green mask represents ground truth label and the red mask represents the error, the difference between prediction and the ground truth. For some good results, we can see the model can still segment accurately after several image frames. Also, here are some other evaluation results. The model has a very high performance common object since it could transfer features from pre-trained weight. However, for other hard cases, the model performance is not very satisfying, such as light blur, high motion, or objects that is hard to separate from background. We also use region similarity, counter accuracy, temporal stability, those three metrics to evaluate model performance numerically. From the plot, we can clearly see that the overall performance on test dataset is relatively good. From the numeric evaluations, we can see our performance is still a little bit lower than original method. overall measure to segment foreground object is valid. Next, I will introduce the system design. The aim of this system design is to support previewing uploaded video with segmented foreground objects, and we expect two outcomes. The first is separate foreground objects with larger than 80% overlapping with ground truth on average. The second is to provide API for video website and a simple web front end for demo. So from this diagram, we can see the user can upload a video in the upload interface. It is actually a website. So once the website got the uploaded video, this video will send to the Flex API through request post method, and the API will get the uploaded file, then it will send back to the backend to do some pre-process, and then use the model to predict segmented label. Finally, it will do the video rendering to this video, then send it back to Flex API. API will return back to the web interface for user to preview. So next, I will introduce our web interface. It is actually based on Django framework, and we use some D3 JS to do some visualization, video JS to play the video, and also jQuery. So we have designed some front end and back end interaction. So first, this is our web interface framework. So this is based on Django framework. This is actually one of the most important programming scripts in the Django. We can see here we actually use a post method. Once the user upload the video, we will send request post to a URL. This URL is actually from the API here, and then it will we can see here the API will get the uploaded file, and if this video already in the cache, it will just hit video in the cache. Otherwise, it will use the OSVOS, our model, to do video pre-process, predict, and render. Finally, we'll send this file back to the Django framework so user can watch it here. So this two line here is just to get the returning video and save it to local, and so run to response here for user to preview it. Okay, so this is the web interface of our project. So here is the homepage. There are some basic introduction of our project, include our GitHub link and some basic introduction. This is the upload interface. The user can upload a video file, give the first mask picture, and give a video name. So once the user press the upload button, it will directly redirect to the video page. So in the video page, the user can preview the rendered video with the segmented object. So this goes, and also some video information about this rendered video. Next, here is a gallery about all the cache render video we use in this project. Also, we do a very fancy visualization. This data visualization, we obtain the data about the position information of the target object in each frame of the rendered video, including the midpoint position, upper left corner position, upper right, lower left, lower right corner position of object rectangular frame. So actually, the first the data file we get is this TXT file. So the first two columns is the midpoint position, and the next two is the upper left. These two are the lower right corner position. So we first do data augmentation to get the other two corner position. Then we convert it to a CSV file for further use in the JavaScript. Then we use the data to do a 3D scatter plot using d3.js, and this 3D scatter plot actually describes the overall offset of the position coordinates of the object we are tracking, corresponding to the motion trajectory of the object in the video. So the x and y represents the horizontal and vertical coordinates of the object. Z represents the time in units of each frame. So this is a demo visualization. So the first video we upload is a cartoon. So it's a relatively steady object motion trajectory, as we can see. Yeah, so it's relatively steady. So we can see the visualization here is also steady here. So the blue line here is the midpoint. The other four is the corner position. So it describes object's motion trajectory. So the next demo video is a goat. So this video is, as we can see, is relatively unstable. Then in the data visualization, it accurately describes this instability. And also the blue one is the midpoint, and other four are the corner position. So finally, we will do. We have done a demo video about our project, as we can see here. So this one, as we introduced before, is based on a Django framework. It is our front end, and this one is the back end of our Flex API. So here the Django will request post to the Flex API URL and to send the uploaded file to the Flex API. And the Flex API here, and we get all the uploaded file and video name, and it will return the rendered video back to the Django. So this is a simple test. We use a Postman to do a simple test. We can see after we send request to this URL, it will send back a rendered video here. Yeah. So this Flex API works. Then we can see our web interface. Yeah. Here is the home page, and we can see some basic instruction of project. And then in the upload page, we can upload the first mask of the video and the video file. Also give him a video name, and we can press the upload button. So since this video is very small, we can preview the render video at once. Yeah, this is the render video. We can see the goat is segmented. And this is the goat offset 3D scatter plot as we introduced before. So it describes the goat, the motion trajectory here. So the blue one is the midpoint here, and the other four on the corner point position. And finally, this is the gallery here. This gallery has all the cached video in our project. We use all this video to do experiment. Okay. 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 Yeah. Okay. This is our reference. Thank you for watching.